Good afternoon, everyone. So I'll be talking on utilization and value addition of timbers for different sectors. So I will acknowledge here because there will be a little bit overlapping what my previous speaker has mentioned, because when utilization is concerned, without mentioning the properties, it will be difficult to cover. So there will be overlapping. Then I'll talk about how the value addition happens. So when you talk about wood, why we should use wood? Because at this moment most of the people they use wood because of the aesthetic value. They feel that it is good, the look wise it is good. However, if you talk about the material property, it is sometimes better than metals. So some of the natural virtues of wood are it's renewable, everybody knows. uh, but in recent context, if you talk about the energy consumption value, it requires very minimal energy in production, and it stores carbon for a long period as long as we are using. So on an average, if you see the whole of life impact on environment of wood use is far better than other materials. And when you talk about whole of life impact, it covers embodied energy, I mean there is energy consumption during use. Like if you have a wooden house, the electricity consumption when you use AC or when you go for room heating also reduces. And at the end of this life cycle, wood can be recycled and reused. So the right side figure says how much difference as far as energy consumption is concerned. Energy consumption happens because of timber and steel use. It's almost 24 to 30 times bigger in steel as compared to timber. And the last, as far as material is concerned, material property is concerned, the high specific strength of wood is really interesting factor in promoting its use as a structural material. So when I talk about high specific strength, I'll just give an example of balsa wood, which is the lightest timber in the world. Its tensile strength is around 73 megapascal, but its density is only 150 kg per cubic meter. If you compare this with steel, whose strength and tensile strength is almost 450 to 500 megapascal, and but it has a density of 8. So if you compare these two, the balsa wood has 2 times better properties than steel. So although because sometimes in structural applications, it is not always the external load that matters. The load of the member itself also matters a lot while designing a structure. So in that context, wood performs better than some of the metals. Then if wood is good in properties as compared to other metals, can we use wood for any wood for every applications? No, because uh, just to qualify for to be used as a structural material or even for non-structural application with low load bearing structure, we need certain mechanical properties, what Dr. Shukla has mentioned already. So these are the mechanical properties what we derive from measure in the wood, and based on the mechanical properties we suggest the end applications. However, there are huge variability in the wood, and in spite of that variability, it is possible to derive to as a acceptable limits as far as all the mechanical properties are concerned. If the mechanical properties will not be acceptable, then it will be difficult for the designers, particularly the engineers, to design a structure. So although there is a lot of variability in the wood, but still it is possible to derive at acceptable values for all the mechanical properties. So as I mentioned, if every wood has mechanical properties, can we use every wood for any applications? No, it's not possible, because there are differences. When you use wood for any specific application, the specific application needs certain mechanical properties, what has been highlighted in the previous speaker. So we have to prioritize the properties, and based on the properties, we have to select the species. So this entire process we call it as measuring the suitability indices of a species, and arbitrarily we cannot suggest any species for any end applications. We have to have some certain scientific background when we use the timber or allocate a timber for specific use, and that is done with in a systematic manner by compiling the physical, mechanical, as well as sometimes with the woodworking properties. So, and the purpose of this entire calculation of the suitability figure is to broaden the resource base, so that some of the primary timbers which are now in short supply and because of over exploitation can have some relief, so that some other alternatives can be utilized in place of primary timbers. So these are the strength parameters what we measure. I don't want to highlight, just to show this. And based on these figures, we suitability indices, we calculate the suitability figures for each applications. And based on the application, we compare the values of secondary timbers with respect to teak as 100. The horizontal line shows the 100, that is the value for teak, and we compare the value with teak, and we see whether it is performing better than teak or at par with teak. So, on the, for example, in case of construction, although sir has already mentioned that these are the values, I just want to highlight the number of species recommended. Although we have almost 160, 150 to 160 species recommended for construction applications in BIS standard in 1986, but unfortunately, most of the timbers, they have been locked up in the natural forest, and we don't have access to those timbers. So, if we want to promote some alternatives, then we have to compare those timbers, and we have to place in any one of the group if the confidence among the consumers has to be brought. So this just to show how the timbers have been classified and how what are the mechanical properties that we need. And similarly, the case with door and window frames, there are almost 75, around 70 to 75 species that is recommended for door and window frames. Again, most of the timbers, we don't have the luxury to avail almost 80% of the timbers from forest. So we are left with only natural timbers. Now, I just want to highlight one parameter here. While the mechanical properties, physical properties, and woodworking properties are important to determine the suitability, sometimes durability and other aspects are also important for certain end applications. So only mechanical property or physical property cannot suffice the suitability of a timber. In certain places, we have to see the durability in as well as the treatability is also a problem. These two are also important when you talk about the suitability of any species for any end applications. So based on that, as are mentioned, we have IWS has recommended certain species in place of secondary primary timbers. So these are the species that is recommended for other applications. So now when you talk about wood processing, because to utilize any timber, processing is the because in tree wood is available from a biological, it is a biological material and available from a standing tree. But once the tree is failed, the whatever moisture is present, that becomes a culprit, and for utilization, so proper processing is necessary to actually make it in a usable form for a longer period. So this is a traditional process. I mean, wood processing is not very advanced, except that some advanced machineries are being utilized. Otherwise, the processing steps are almost, whatever we have been following from many centuries. So the important steps are log sorting and grading. I'm not highlighting here the importance of felling because the systematic felling is not being practiced nowadays. It's very less. Whatever we are getting mostly from plantation origin. So the first step comes is log sorting and grading, then conversion, seasoning, and preservation. So I'll just highlight the importance of sorting and grading. Because we don't have, as I mentioned, we don't have the luxury of getting bigger dimension trees from natural, what we are getting from natural forest. So now we are ended up with small garth timbers from plantation species. So these timbers have their own merits and demerits because the garth is also small. Sometimes a lot of defects used to happen present. So the without the proper grading, the conversion output, when we go for conversion, the output may be poor. So grading and sorting is very important as far as the output is concerned, because while productivity in the forest is one way to improve the wood availability, so better output from the conversion is also one of the approaches to improve the wood availability to the consumers. So the traditionally the log sorting is carried out based on species, diameter, length, and end use. Then it ensures maximum recovery, and it helps to predict the proportion of high quality timber, and ultimately it helps both the buyer as well as the seller to settle at the better price. So they know that what they are selling, and the seller knows what he is selling, and the buyer knows what he exactly is buying. Just to give an example, what is the importance of grading? Uh, Traditionally, we do visual grading, or to some extent acoustic also by experienced people, by knocking the log because of some presence, just to find out the presence of hollow or knots in the, decay in inside the wood. But in the last couple of decades, a lot of scientific methods have been utilized in grading logs, mostly X-rays as well as ultrasound. then it is possible to grade the timber in a more precise way, because visual grading can be very subjective and depends on the experience of the person. However, if you go for mechanized grading, that variability can be minimized, so that the output can be improved. Just to give an example, in different species, particularly in softwoods, there are three grades of timber: grade 1, grade 2, and grade 3. The grade 1 is the best grade, and grade 3 is the poorest grade. So if you without grading, the recovery, it is the comparison between sawmill and what is the recovery after CT scanner. So they scan the log, and we can see that total recovery can be increased by another 46%. And if you see the grades, the maximum recovery happens only in the grade 3 timber, which is normally we throw it, thinking that it may not be usable. So with proper grading, we can improve the conversion output, which can also solve as a way of saving a lot of wood. It is equivalent to producing more wood. Although we are not producing more wood, we are actually producing more wood from the available logs. And conversion, still we have been following the traditional conversion practices. So basically there are two types of conversion. When in the first conversion, log breakdown happens to slabs, and mostly it is done by radial sawing, sorry, band saws, or to and this primary conversion can be done either by flat sawing or by radial sawing. The sawing itself determines the quality of the material. If we can go for flat sawing, we can get a maximum recovery. The recovery can be around 80 to 70 to 80% of the total log. However, and the aesthetic value of the tangential plank cuts are really good, and it is easy to cut also in the sawmills. However, whatever planks we get, most of them, they are not very dimensional stable because of shrinkage and swelling. So in order to minimize, the other method have been suggested, like there are balanced tangential sawing or even radial sawing. And in radial sawing, the disadvantage is that it's very time consuming and labor intensive. And however, the advantage is that it's very dimensional stable. However, when you talk about plantation timbers, it is very difficult to follow this sawing if it has a small girth, because first the log is converted into quarters, and once we cut into quarters, the availability of the plank size will be very small. So this can only be feasible when the logs are of considerable diameter. And it is expensive also, because it needs a lot of time and manpower. It is expensive as compared to tangential sawing. However, when high value products are needed, it can fetch a premium price, but not in case of normal usage like furnitures or normal usage.